Hey, Miss Marion here. We're starting Unit 5, so make sure you have a Unit 5 workbook, and we're going to go over Lesson 1 and Lesson 2. It's actually not very long, so don't complain. So learning targets. So today I'm learning about rules of functions, and by the end of today, that is our success criteria. I know when I got it, when I'll be able to write a rule for a function diagram. So all of this stuff is new, and so make sure you have a workbook and something to write with. All right, so first of all, on page 2, make sure that you write down the definition of a function. It is a rule that assigns to each x exactly one y. And we're going to be talking about functions for a while, and making sure you actually have this written down on the bottom page of page 2, so that you can refer back to it when we are been going through a lot of different things. So a rule can be anything that always produces an output. So remember, an output are all the y's for any given input. That is our x's. So it's something where I can put in an x, do something with it, and then get out a y. So here is a function diagram. So notice how we have an input, and then we have a rule that we do, and an output. So it's kind of like taking bread and putting it into the toaster and turning it on. The rule is we are going to toast the bread, and then the output, which pops back up, we're going to have toast, right? So an input, so we have an input, rule, and then an output. And these are the input diagrams that we're going to be working with for today. So here's an example of an input diagram. And so notice again, we have, we're going to put something in, we have some type of rule, and then we have an output out. So you're going to need a calculator. So notice how we're going to put in 3/2. So we're going to put 3/2 in. Our rule is to multiply by 2. So grab your calculator, do 3/2, multiply that by 2, press enter, and then what is our answer? Our answer is going to be 3. And then again, now we're going to change our input. Our input is 2. So we're going to have 2. We're going to multiply it by 2. That answer is 4. And then we have 5/2. We're going to multiply that by 2. And then we have 5. So again, this is a way of using an input-output table. So input, outputs, and then making a table along with it, especially with our rule diagram. So now we're going to go ahead and we're going to try some ourselves. So on page 4, make sure you turn to page 4. We have A. A says, and this is an example of the first one, our rule is we are going to add 1, then multiply by 4. And this is done a little bit differently. So if you put everything into your calculator and press enter, you're going to get it wrong. So we actually have to add 1, and I'm going to write in here, press enter, then multiply it by 4. So if we were doing 3/4, we're going to do 3/4 plus 1. We're going to press enter. So 3/4 plus 1, press enter, and we should have it as, so you can either have 7/4 or it's 1 3/4. And then we're going to take this and we're going to multiply all of that by 4. So we're going to take our answer, multiply it by 4, and then this is how we get 7 back. So we put in 3/4, did all this stuff, we got 7. So now our next one is we're going to do 2.35. So grab a calculator, we're going to do 2.35, right? We're going to take that, plus 1, 2.35 plus 1. Okay, so that is 3.35. Sorry, 2.35 plus 1. So we have 2.35. We're going to add 1. That's 3.35. We're going to take that. We're going to multiply it by 4. So we'll do 3.35 2.35 times 4. Our answer is 13.4. And then 42, let's change that color. So 42 is our input. So we're going to say 42 plus 1. That is 43, right? 42 plus 1 is 43. And then we're going to take 43. We're going to multiply it by 4. So our answer is 172. All right, let's try B. So again, we're going to name the tenths. So remember, the 3 is the tenths. The 5 is the hundredths. And the 8 is the thousandths. So if we have 3/4, so let's take 3 and let's divide it by 4. So 3 divided by 4, right? And that's 0.75, and we want the tenths position. Well, what is the tenths position? That is the first decimal place. That is the reason why our answer is 7. And then we're going to look at 2.35. We want the tenths position. That answer is 3. And then we're going to look at 42. Remember, it's 42.0. So the tenths position is 0. So notice how we're just kind of putting all these things. So the rule is that middle part. We're going to take different numbers, and then we're going to take it and do whatever rule is sitting there, and then we're going to get our answer out. So this is our input, because that's what we're putting in. And then here's our output. So here is our X. Here is our Y. All right, page 5, letter C. We have 3/4. And what is our rule? Oh, we're going to write 7. All right, so if I have 3/4, my rule is to write 7. If I have 2.35, what's the rule? We're going to write 7. If I have 42, what's the rule? We're going to write 7. If I put 100 as the input, what's our rule? We're writing 7. So this one's a little bit easier once you understand it. All right, also on page D, we have X. So we have divide 1 by the input. All right, so we're going to put, so the first one is we have 3/7, right? And we're going to divide 1 by the input. So really what we're doing is 1 divided by 3/7. And put this in as a fraction. So do 1, divide, make it a fraction, 3/7, press enter. Oh, that makes it 7/3. All right. So if we put 1 in, we're going to say 1 divided by the input of 1. We're going to get, oh, that's 1. Then we're going to put in 0. And we're going to say, okay, we have divide 1 by the input. So we're going to say 1 divided by 0. And honestly, this is what is called a divide by 0 error. So our answer is error. And that is correct. There's a reason why. I'm just not going to go into it right now. So now we're going to go into function diagrams. So we have an input, a function diagram, and then an output. So if we're looking at a person is 60 inches tall, do you know their height in feet? So we can take the 60 inches tall, we're going to convert it to feet. How do we do that? We're going to take the 60, we're going to divide it by 12, and that makes the 5 feet. So again, this is an example of an input-output diagram, and we're going to actually be making those and creating those ourselves. All right, so on page 11, it says say yes or no for each question. If it's yes, we're going to draw an input-output diagram. If it's no, I'm going to actually change that. We're just going to say, you know what, it's not going to happen, and then we're going to go ahead and move on. So the first one is A, and this is on page 11. A person is 5 feet tall. Do you know their height in inches? So right now we have the feet. Eventually we want to go into inches. So kind of think about that. How do we actually draw this? So we know we have an input-output diagram, right? We have that box. We have the arrows that kind of come out around. So I know that there are 12 inches for every foot. So if I have the 5.5 feet, and I'm trying to figure out inches, I need to go ahead and I'm going to multiply by 12. So let's grab our calculators. Let's do 5.5 multiply by 12. And that gives me out 66 inches. All right, let's look, again, still on page 11. We're going to look at B. A number is 5. Do you know it's square? So what does that mean as far as the square? Well, what it means is we're going to take the 5, and we're actually going to go ahead and we're going to multiply it by itself. So a square is to the number multiplied by itself. So we're going to take our 5, we're going to put it in. Here, I'm going to change that color because I'm going to show you why. So we're going to take that 5. So I'm going to take 5 and I'll multiply it by itself, which is 5. And then if I figure out what my answer is, well, 5 times 5 is 25. So yes, we can make an input-output diagram for this situation. All right, letter C, it says the square of a number is 16. Do you know the number? So let's think about this really quickly as, can we actually do a input-output diagram for this? That answer is no. And some of you are like, well, why, Miss Marion? So a number multiplied, so we have to think about a number multiplied by itself is going to make 16 is really what it's asking. So we know we can take 4 and multiply it by 4 and we can make it 16. But is there another number multiplied by itself that also makes 16? We can do -4 times -4. And we know that is also going to be 16. So remember, I can only have one input and make one output. So output. So is there, in this situation, we have 2 inputs. So we're looking at 4 and we're also looking at -4. So this is the reason why this does not work. We cannot make an input-output diagram for this because we have 2 inputs that makes only one output. All right, let's look at letter D. So we have a square. So it's a square, has a perimeter of 12. And can we figure out the area? And the answer on this one is yes, we can, right? How do we go ahead and do that? Right? So we're going to find the side length. Of the square. And then square it or multiply it by itself. Square the side length. Do it that way. So this is how we figure out if I have my perimeter. If I know the perimeter, can I figure out the area? So think about a square. How does a square actually work? So we have it where a square, so we have the perimeter of the square, right? So we have like a side, plus a side, plus a side, plus a side, right? So we have 4 sides added together makes 12. All right, so if I add all the sides together, it makes 12. So what number can I multiply? Or not multiply, can I add together? So this side length is 3, because if I have 3 plus 3 plus 3 plus 3, that makes the 12. So our side length is 3. So we found the side length. We're going to take it and we're going to square it. And we talked about squares before. We're going to take the number and multiply it by itself. So then 3 times 3 is 9. So then the area is going to equal 9. So the number that we actually did put into this is we actually started with the 12. Here, I'm going to change this color. So the 12 actually needs to come into here. We found the side length and then we multiply it by itself to get the 9. Okay. So input was 12, did all that stuff, and then output was 9. All right, number E on page 111 or page 11. A rectangle has an area of 16 centimeters squared. Do you know its length? So think about a rectangle. Right? A rectangle is we have a length and a width. And its area is 16. So let's think about different ways we can find 16. So let's say that my length was 2. Actually, that's a highlighter. So let's do our length as 8. Width is 2. So 8 times 2 equals 16. Now, is this the only way we can actually do this? Not really. We can say that our length is 16, but our width is 1. So 16 times 1 also makes that 16. So can this be a function diagram? Can we only have one input and getting one output? That answer is no. This does not work because, as we kind of showed with the green stuff and the black stuff, we actually have two different things going on. So can we make an input-output diagram? Unfortunately, we cannot. All right, so we are looking at F. It says you were given a number. Do you know the number that is 1/5 as big? So think about that. Could we actually do that? So I want you to actually try it. So go ahead and try this and then come back to me. All right, so our answer is yes. Can we do this? Yes, we can. Let's kind of talk about it. So remember, we need an input, right? And it does right now, it doesn't matter what input it's doing. And then we're also going to get an output. So what does it mean as 1/5 as big? We're actually going to multiply whatever input that we have by 1/5. So could I put any number in there and multiply it by 1/5 and get a number out? Yeah, absolutely. So yes, we can make an input-output diagram, and this is also a function. All right, we're looking at G. You're given a number. Do you know its reciprocal? So anybody remember that? So reciprocal, the definition of reciprocal is we're going to divide 1 by whatever input it is. So if my reciprocal, it was 2. Sorry, if my input was 2, my reciprocal would be 1/2. So can we draw an input-output diagram about this? Yes. Right? So we can take our X, our input. So let's put X like this. Let's do input. And what we're going to do is we're going to divide 1 by the input. Right? And our input was X. And what is the answer that we would get out? Well, we're going to take 1 and we're going to divide it by the input, which is X. So can we make an input-output diagram about this? Absolutely, we can. So remember, all of our inputs, those are the X values. Outputs are our Y values. And a function is what is considered one-to-one. So one input for one output. And that is what a function is, and that's what we're supposed to learn for today. So for your homework today is lesson 5, unit 5, lesson 2, practice problems. And then, yes, we're going to put the answers into Canvas. So the practice problems, they start on page 16 and they go to page 18. So again, that's our homework for today. Make sure you put it into Canvas. Thanks. Have a good day.